All right, so let's go ahead and give this one a shot. I know that some of us might feel confused on this one. I totally get it, but I got your back. So let's get the timer out of the way and let's give this one a shot. So here we go, my party people. First things first, we're going to read the question. So just to make it very clear, yes, this correct answer is listed here. It is C, 16 hours, but let me go ahead and show you how we're going to get there. So first thing, how many hours will it take to completely drain the pool? Okay, sounds good. So let's say we have, this pool here, and we're just trying to drain the pool. Okay, cool. Then we have all this water, yada, yada, yada. And again, we are trying to drain the pool. So let's read the information here carefully to understand what kind of problem this actually is, because this can be modeled as a distance, rate, time question. It can be modeled in that way as a rate word problem, but at the same time, we're mixing in volume. So this is going to be found arithmetic reasoning, unit number, and that's going to be, that's going to be 8, 9, 10. So that's going to be arithmetic reasoning unit number 10 for volume word problems. And let me show you why that's the case. So going through the information, we see here that it says a rectangular swimming pool is 40 feet long, 20 feet wide, and has an average depth of 5 feet. So we have the length, the width, and the height. That's right, Sua. Length, width, and height are given here. And then it says that the pool's drain can remove water at a rate of 250 cubic feet per hour. So the pool's drain can remove water at a rate of 250 cubic feet per hour. So how do we do a question like this? Well, you think about it in the sense of, hey, what's the rate, the flow rate, draining rate? That's going to be 250 cubic feet per hour. So this is what this tells us, my party people. What this tells us is if this is our rate, 250 cubic feet per hour, our distance that we're trying to accomplish, or the amount that we're trying to get rid of, the amount of water, is going to be in cubic feet. And then the time is going to be in hours because of the way that the rate is written. Cubic feet, that's the distance. Per hour, that's the time. Now, this is where we have the huge hint that, cubic feet. Everybody, what geometry idea is the only idea that can be written in cubic feet or cubic units per se? Exactly. I've taught you this. It's volume. Volume is the only unit that is shown in cubic units. And so that's how we know that what belongs here is the pool's volume, because that's what you're trying to drain. That's the amount that you're trying to accomplish, the volume of the pool. And so how do we find the volume of the pool? We can find that right over here. We can find the volume by doing the length times width times height. The length was 40, the width was 20, and the height, the average depth in this case, was 5. Once we have that, we multiply. 40 times 20 is 800 times 5. And then from there, everybody, 800 times 5, that's going to be 4,000 cubic feet of water. That's how much water the pool holds. Once we found that volume, 4,000 cubic feet, again, that's the amount of water we're getting rid of. That's how much water we are draining. This is the rate at which we're draining at. And now we can plug this all in to figure out how much time it'll take. So just like I said, distance equals rate times time. Trying to get 4,000 cubic feet of water at a rate of 250 cubic feet per hour. And then we multiply that by t. To get t, or time by itself, we just divide by 250. on both sides. Once we do that, we will go ahead, cross out on the right side because we're canceling out. And then we have t equals what? And so that's where we'll divide, and we can go ahead and do it right over here if we'd like to. 250 going into 4,000. And then we have 250 going into 400. That's just one time. Subtract the 250, and you get 150 left over. We'll drop the 0 to get 1,500. 250 goes into 1,500 8 times. 4 times would be 1,000. 5 times would be 1,250. And then from there, that's going to be 6 for 16. Because that would be 1,500 at that point. And you can check here on the side, 250 multiplied by 6. Excuse that little error. 0 times 6. 5 times 6 is 30. And then 2 times 6 is 12. Carry the 3 is 15. So there we are. And so it will take 16 hours to drain the pool at that rate. So right there, 16 hours for this problem. The premise of this problem, I know I'm running out of time. The premise of this problem was just going to be dividing the volume of the pool by the rate at which we're draining the pool to get how long it'll take to drain the pool. And that's how we get 16 hours. And there we go. So who here feels like, individually, yeah, you understand volume, yeah, you understand rate, but together, this one kind of tripped you up? Yeah, it can happen, right? It can definitely happen. So that's why it's important to, again, not stick to just one concept and one concept only over and over and over again. Remember that this test can and will mix certain topics together, as you've seen throughout this practice test. All right, so let's move forward here with our first question of the day. We always want to begin, per usual, with the question sentence. So we see here that it says, what is the area of the pool? And just like in the previous class or the previous times that we've talked about this, the moment that you see one of those hyper-specific geometry words, like area in this case, we always want to ask ourselves, well, what shape? Because remember, depending on the shape, the formula for the area might be different. So with that said, everybody, in the chat box, what is the shape that we're dealing with? We know that we're dealing with, right there, a rectangle. So we know that we're dealing with the area of a rectangle. So before I even continue, I'm just going to remind myself that I want area, and I know that the area of a rectangle is going to be length times width. And I'll just have that written down because guess what? If I want the area of this rectangle, it really, really looks like all I need is the length and the width. If that's given to me, great. If not, I'll have to figure out what to do. So it says that the swimming pool is 20 meters long, 8 meters wide. So with that said, nice and easy, the length is going to be 20 and the width is going to be 8. So we have that together. So the area is going to be 20 multiplied by 8. 20 times 8 is going to land on 160, but that's not what I care about. Let's go ahead and remind ourselves what the units are going to be for this solution. What are the units going to be? Yeah, they're going to be meters squared. So you can say m squared or meters squared. Either way, it means square meters, so you're good. But there we are. There we go. And we are all set. The correct answer for the first question is B, 160. So feels like a pretty straightforward question, but let's go ahead and turn our attention over to trying another one out. So here we go, my party people. Let's keep it going.